Hey everyone! In this quick demo, I'll show you how Chain.love can simplify your development process. First of all, Chain.love is a platform that lets developers discover, compare, and access Web3 infrastructure services, all in one place. So I'm heading to arbitrum.chain.love. Here I can see all available service providers for the Arbitrum network, neatly organized by categories. Let's say I'm a developer looking for an RPC provider. I select the RPC category and choose a paid option. Now I can see all providers in one view. Their data is unified, fully comparable, and easy to analyze. I can select multiple providers, click Compare, and instantly view them side by side in a single interface and unified API. From here, I can add comparison metrics. For example, limitations or pricing, open their documentation, remove or share selected options with teammates, all within seconds. Other categories are also available along with a search bar, filters, and an AI search assistant. Let's try that. I'll ask, who's the cheapest RPC provider on Arbitrum? Please compare pricing plans. As you can see, it makes a live API call to our open source GitHub database and returns a detailed breakdown with reasoning. This helps developers quickly make informed decisions about the best fit for their project. That's the value of Chain.love. It replaces the old, inefficient process where developers had to browse dozens of websites, read docs manually, and piece everything together. And one more cool feature, our embeddable widget. Here, I'm on a Gitbook page. The toolbox you just saw can be embedded directly into network documentation, giving developers the same powerful search, filters, and comparisons without leaving the docs. So that's Chain.love, the fastest way to discover and choose the best Web3 infrastructure for your needs. Thanks for watching. Performance module allows tracking API providers' performance, load balance between them, and even sign contracts to provide additional compensation for providers fulfilling their duties correctly. As a user, I would need to connect my account, go to Provider section, and select Create New Configuration button. For the sake of this demo, we can create either for RPC or for subgraphs, but among categories here may be any custom API name the configuration for future references. Then, you will need to either select some of the providers from the toolbox or add your custom provider. For now, there is no much difference between these two options, but as more providers will officially join Chain.love platform, the more automated will the purchase process look from the toolbox perspective. For now, let's add 2 providers and manually enter the URLs we got from these providers. After we see a summary, let's attach our credit card to activate it. Now let's assume we have a private deal with one RPC, which provides us a discount for our requests, but one RPC at the same time has slightly less uptime. So we want to ensure that when it goes down, we have Alchemy as a backup. Even if it costs us more, the downtime is not accessible. We set one RPC as a primary provider and Alchemy as a failover. We pay for the load balancer and getting to the query keys section to get our access key for the Chain.love load balancer. However, our system is not aware about the health status of the providers, so the load balancing won't work effectively. To enable it, we need to additionally enable monitoring of at least the primary provider. For the sake of this example, let's set monitoring with different health parameters. It can be either the block amount or the time in seconds. System always chooses the lower number to be effective, which is very useful for the networks with non-predetermined block time. On the subscription tab, user may manage all the aspects of their subscription. For example, see when the next payment is going to happen, attach or change the existing credit cards, and download invoices. Now we can use our query keys to access a load-balanced endpoint. In the last part of the video, we are going to cover the contract creation mechanism. Contract allows defining parameters, such as uptime and latency, to compensate provider, only if their performance surpasses certain conferable limits. In this example, we are signing a contract with one RPC to pay them wrapped Ethereum if they are not going to violate the 120 blocks and 240 seconds policy more than 5 times in the 30 minutes period. This gives the networks and the dApps a real leverage in the negotiations with the service provider. With that, we conclude our demo.